Hey guys, I'm back. We're still talking about triangles. What we're going to talk about today is the altitude of a triangle. Now, if you remember back from finding the area of triangles where you had the formula 1/2 base times height, the height is the altitude of the triangle. Just two words that mean the same thing. And we're going to talk about how you find the altitudes and then what the altitude shows you. So let's get to going. So the first one is that the altitude is the perpendicular segment that goes from the vertex to the line that contains the opposite side. Now, let me talk about that. It doesn't say that it contains the opposite side, but it is to the line that contains the opposite side, because there are occasions in which the altitude actually does not go through the side of the triangle, and we'll talk about that in just a sec. So every triangle has three altitudes. Those altitudes can be inside the triangle, outside the triangle, or on the triangle. So we're going to look at the three different situations here. So the first one is when it is inside the triangle, and that would be one that looks like this. So it goes from this vertex perpendicular to the opposite side. It's going to be inside the triangle. Okay, here's the other one, and you should have been able to remember seeing these from when we do area. So again, it goes, I wish I could get rid of that there. Goes from the vertex down. This time it's going to be on a line containing the side, not actually on the side. And here's your last one, in which your altitude is actually, and this is when it's a right triangle, when your altitude is going to be on the outside. So again, here was this one. I don't know why that does that, but okay. So those are our three. So we're going to go back, to the definitions, and I'll give you a minute there to look at those three types of altitudes, and you'll be drawing those in anyway, but you should remember seeing those. So we've got the acute triangle, the obtuse, and the right, and how it looks in each one of them. So now the next is, if the lines that contain the altitudes are concurrent, in other words, if all of those altitudes meet in one spot, we do call that spot the point of concurrency. And it also has a name for it, just like what we had, the centroid. This is called the orthocenter. Orthocenter. Okay? So when all the altitudes meet, that is on the orthocenter. And that's what it looks like. So this one is an obtuse triangle, and so you'll notice that all of the altitudes, or not all of them, but here's an altitude that is outside. Here's an altitude that's outside. And then here's your altitude. And where they all three meet, now that point that they're going to meet, guys, may not all be inside. Again, it could be inside, outside, or on the triangle, just like where your three altitudes have. So the orthocenter could be in any of the three positions also. Okay, let's look at some examples here for you. And we're going to be looking at finding the orthocenter. And what it gives you is 3 points, K, L, and M. And let's get those graphed on there. There's K, it's at 2 and -2. L is at 4, 6. And M is at 8, -2. So we're going to go ahead and draw in our triangle real quick. So there's my triangle. And now they want us to find the orthocenter. So they want us to find that segment or line that goes from the vertex that is perpendicular to. From the vertex perpendicular to, vertex perpendicular to. So what you might remember is in algebra, where you find the equation of a line that is perpendicular to and goes through a certain point. So that's exactly what we're going to be doing here. So let's ask you first to remember, if you have two lines and they're perpendicular to each other, what do you know about them? What do you know about two perpendicular lines? And yes, they do form right angles. But in terms of algebra, what did we learn about two perpendicular lines? Now, hopefully what you remember has to do with slope. And so in this case, we're going to go ahead and find the altitude from M to KL. M to KL. Okay, so we're just going to find one. You would find all the other three the same way. So this does become a little bit of a longer process because you have to do this 3 times. So we're going to do the slope of KL. Now you can do the formula or you can do rise over run. I just did a quick rise over run, but I would not say not to do the slope formula. That might not be a plan. So I went up 8, right 2. I have a 8 over 2, which is a slope of 4. That means that the perpendicular to it would be a negative 1/4. So this point over to this line perpendicular would have a slope of a negative 1/4. Now, one of the things that you could do is, if you're just drawing it, is you could just draw it in. Negative 1/4 would mean up 1, right 4. 1, 2, 3, 4. Now, I didn't put that pointed there, but you could. So you could put a point right there and then draw the line between those two. If you wanted to go again, you could rise 1, 1, 2, 3, 4. It's going to hit at 0, but you could draw you a line through there, especially if you're graphing it on graph paper. So that is definitely an option to do. Now, if we are doing it as we did in algebra, and we know it has a slope of a negative 1/4 and it goes through the point 8, negative 2, then I'm going to put it into my y equals mx plus b, substitute my things that I know. My x is 8, my slope's a negative 1/4, sorry, and my y is a negative 2. I'm going to solve for b. There's my equation. It does go through 0, just like what we said. You could just draw that line. So you could do that. Definitely. So you've got 2 options here. One would be to use your y equals mx plus b and write the equation. The other would be to draw your triangle, find this one's slope, negative reciprocal slope, and then just do a count over. And that would work. And so you would do the same thing for your next one here. So if I was doing, well, this one would be an easy one. It's got a slope of 0, therefore the perpendicular is going to just be straight down. That's an easy one to do. Over here we would have a rise of 6 again, a run of 1, 2, 3, 4 to the negative. So that would be a 6 over a negative 4, negative 3 halves. Negative 3 halves reciprocal would be 2/3, right? And so then I would, from this point, because I'm coming across to here perpendicular, I would do 2/3. So rise 2, run 3. So it would hit that point, rise 2, run 3, this point, and you could draw that line through there. Okay? So let me give you an example. So there's our first one. There is our second one, we just said, and the other one would have a, and I don't know that I got it exactly on there, we said 2/3, 2, 3, 2, 3. So it's going to be a little bit, I should have made that just slightly steeper, but I was just eyeballing it there. Okay? So that is finding your orthocenter.